All right, question 1 asks us to just plot these 4 points in the complex plane. So remember that this is where the real numbers hang out and this is where the imaginary numbers go. So if I have 1 plus 2i, that's equivalent to 1 comma 2. So I would just go over 1 up 2. So that's the first point right there. So that one is 1 plus 2i. Next we have 3 minus I. So I'm going to go 3 in the real and down 1 in the imaginary. So that's right there. There's 3 minus I. Negative 2 plus 2i, so that's negative 2 in the real, and then up 2 in the imaginary, so that's right there. And then we have this one, which has an imaginary 0 plus I in front of it, so we go 0 in the real direction and up 1, so that's right there. So that's I. And there you have it. That was probably the hardest thing we've done all year. Whew. Let's call it quits. Nothing else for the rest of the year. We're done. Question 2 asks us to write these complex numbers in trig form. I personally find it much easier to just do a quick graph of them. So this is really 0 plus 3i, so it's going to be right there. That's going to have a radius of 3, and it has an angle of 90, but we're being asked to write it in radians, so I'm going to do pi over 2. Done. This guy, if I go to graph it, it's going to be up here, 2, 2. It's going to have a radius of 2 rad 2, and it has an angle of pi over 4. So I just write it as 2 rad 2 kiss pi over 4. When I'm down here, and I go to graph this, it's going to be up here. So we have negative 2, and then 2 rad 3. So this is following the pattern x rad 3, so this would be 2x. This is going to be 60 as a reference angle. So radius is 4, kiss. Angle is going to be 2 pi over 3. So we're done. One of these is not like the other. This is a calculator question. So I need to find the radius of this thing. So I'm going to do r equals the square root of 3 squared plus 2 squared. So that's the square root of 13. Didn't need a calculator for that. Do need it for this next one. I'm going to do tan theta equals y over x, or b over a, 2/3. And when I plug this in the calculator, I get a reference angle, which just so happens to be the real angle, of 0.59. I know it's the real one because this is in quadrant 1. Reference angles always exist in quadrant 1. So I get square root of 13, kiss, 0.59. 3a, we need to find the standard form of these complex numbers. So we write it as a plus bi. So I'm just going to basically expand these things out. This is really saying 5 cosine negative 60 plus 5 times I sine of negative 60. So let's see, cosine negative 60 is going to be positive 1/2. So this is 5 times 1/2. Up here I have 5. Let's see, sine of a negative 60, that's going to be a negative square root of 3 over 2. So I have 5 halves plus a, not plus, silly, a minus 5 rad 3 over 2i. So this is the answer for that one. B, I'm just going to do the same exact idea. I'm going to do shorthand now, so I'm not going to write it all the way out. I'm going to do square root of 2 cosine of a 7 pi over 6. That's going to be a negative square root of 3 over 2. And then I'm going to have, let's see, sine of 7 pi over 6. That's going to be a negative 1/2, which makes sense. They'd both be negative. 7 pi over 6 is in quadrant 3. So if I just kind of simplify this, I get a negative square root of 6 over 2 minus a square root of 2 over 2i. What are we doing? Multiplying? All right, multiply. So we just follow the formula, take the radiuses, and multiply them together. So this is going to be 14. Kiss, add the angles on the inside. So this is going to be 155. That's not a special angle, so we leave it. Boom, done. That was super hard. Over here, same exact idea. We're going to multiply. So 3 times 5, that's 15. The last time I checked. Kiss. Ooh, I got to add these things together. All right, so let's see. I need them to have a base of 12 probably. So that's going to be 3 pi over 12. This guy's going to be 20 pi over 12. So when I add those together, that's 23 pi over 12. Not a special angle, so I leave it. 5, we got to do division. So I just follow the properties. It says divide the radiuses, subtract the angles. So I'm going to have 2/3, kiss, and I subtract these guys. That's going to be a negative 30. Now, I am going to just show us the next step, so I'm going to bring this out to the next level. So I'm going to have 2/3. Cosine of a negative 30 is a square root of 3 over 2, plus sine of negative 30 is going to be a negative 1/2. times the I value. We don't want to forget that. And now if I just distribute these things through, I get a square root of 3 over 3 plus a negative 1/3 I. Boom, done. Same thing, 6 divided by 3, that's 2, pretty sure, almost positive. 5 pi minus 2 pi, that's going to be 3 pi. All right, so 3 pi, we could find a coterminal angle to that. That's the same as just pi, right? Right, you know, if we go 1, 2, there's 3 pi, so we could have just said pi. And graphically, this is really easy to figure out what it's going to be. It's going to be negative 2 plus 0i. 6 wants us to do the product and quotient of these two complex numbers using standard form and using the trig form. So let's just do the standard form first. So when I do multiplication, I'm going to have 2 minus 2i times 2 plus 2i rad 3. Hate it already, got a FOIL, that's 4, plus 4i rad 3 minus 4i, and then minus 4i squared rad 3. And then I'll just group non-I terms together. So this is really a negative 1. So I'm going to have a 4 plus 4 rad 3. Those guys don't have any i's. These two do. So I'll have plus 4 rad 3 minus 4 I. And there we go. That's going to be officially what the answer is. If I type this all on the calculator, I'm pretty sure I get 10.93 plus 2.93 I. Now, if I do division, that's going to be annoying. So I think I'm actually going to jump and do the complex numbers so I can show the multiplication one at the same time. So I need to figure out what this guy is in trig form, so I'm going to just graph it. It's 2 negative I. It's down in the 4th quadrant. It's going to have a radius of square root of 2 times 2. And then its angle is going to be either negative pi over 4 or 7 pi over 4. It really doesn't matter, so that's that guy. This one is up in quadrant 1 with a 2 and a 2 rad 3, so it's going to have a radius of 4 and a reference angle of 60, so it's going to be 4 kiss pi over 3. So doing the multiplication of these, I just multiply the radiuses, so 2 rad 2 times 4 is going to be 8 square roots of 2 kiss, and then I just add these things together, so 7 pi over 4 plus pi over 3. And I have no idea what that is. What is that? That's 25 pi over 12, right? That's 21 plus 4, 25, okay. So 8 rad 2, and then I just do this in the calculator. I'm going to get this 10.93 plus 2.93 again. Doing division the old school way, we have to actually do a whole bunch of work. It's super annoying. We need to multiply by 2 minus 2i rad 3 top and bottom, so the conjugate of the denominator, to help us figure out what this is. So foiling that stuff out on top, I get a 4 minus 4. I'm actually curious if I just messed that up in the last one, but I can't remember now. Not going back. Minus 4i plus 4i squared rad 3 all over, let's see, 4. Oh man, this is tricky. I got to do math in my head. Let's see, 4 times 3. So I think this is going to end up being plus 12 when we're all said and done. So grouping the top no I things, that's a 4 minus, because that's I squared, so 4 rad 3. And then up here I can factor out a negative sign, so I'll have a 4 rad 3 plus 4 times I, and then I can just do over 16 for each one. And yes, they totally reduce, and I could do that. I'm just not going to. I didn't write down what the decimal is of this, so I have no idea. If I'm doing the division, I'm going to have 2 rad 2 over 4, kiss, and then I'm just going to subtract 7 pi over 4 minus pi over 3. So this is square root of 2 over 2, kiss, and then let's see, this is going to be 21 minus 4. Oh god, I'm 17. I don't know, math is not my strong suit sometimes. And I'm sure if I plug these into the calculator, square root of 2 over 2 cosine 17 pi over 12, I'll get whatever that number is. Same thing if I used sine instead. Whew, there we go. I think that's it. Yeah.